Alright, next we got system of equations. Systems of equations means that you got two or more equations that all have the same variables, and the solution is a set of points. Like if you've got x's and y's, the set of all those points make all the equations true. If you've got two equations, you need two variables. If you got three equations, you need three variables. Here's what a linear system of equations looks like, and you may remember these from algebra last year, where the a, there's my pen, there it is, the a, the b, the c, these are just numbers, so are the d, the e, and the f, etc. So again, I've got two variables, I've got x and y, so I need two different equations in order to solve it. If I threw in a z, then I'd need a third equation. That's if I was going to be that crazy, but I'm not gonna yet. Okay, here are the three different ways that you can use to solve a system of linear equations. First one is the easiest one. If you don't mind graphing the equations, you'd have to graph both lines, sort of like this, and then you find the point of intersection where they both meet. Problem with that is that it's not very accurate, especially like on a piece of graph paper or something. If you're going to put it in a graphing calculator, you'd always have to solve for y before you can put it in. Usually we use number 2 and number 3, the substitution or elimination. On substitution, you take one expression and then you plug that into the place in the other equation. You have to put it into the other equation, not into the same equation. And the third one is elimination. And on elimination, you're trying to get rid of either the x or the y by adding or subtracting a multiple of one of those equations. So let's look at a couple of these. First one, it should be obvious that we should do this one by substitution. And the reason why is because y is already by itself. I can take what y is equal to, and that's 2x minus 1, and I can substitute it in for y into the second equation. You never substitute it back into the same equation, because then you're just going to go around in a circle. So I rewrite this equation as 2x, and in the place of this y, we're going to write 2x minus 1 from the top equation equals 3. Now just solve it. We got 4x minus 1 equals 3. Add the 1 over. So x equals 1. But we're not done yet. That's just half of the solution. We need to find the point. We need to find the y coordinate. So I can take this 1 and substitute it into either one of these equations to find out what y is. This first one's the easiest one. So y equals 2. I plug my 1 in for x minus 1. This is 2 minus 1, which is just 1. The way that I write my answer is as an ordered pair, x comma y. So 1 comma 1. If I were to graph these equations, that's where they both touch. Next. Except for this is a pro tip. Pro tip number 2, when you're solving a system of equations, you always want to make sure that whatever you substitute, don't substitute it back into the same equation, put it into this second equation. So let me show you what happens if you don't. So let's say I take this 2x minus 1 and I substitute it in the same equation. So that's what y is equal to. So I'll put 2x minus 1 equals 2x minus 1. Let's see, there's a 1 on both sides, so I'll just go ahead and add 1 to both sides. Those cancel out, okay? 2x equals 2x. Oh, there's a 2x on both sides, so let's just go ahead and subtract that from both sides, and then I've got 0 equals 0, which is true, but not really helpful. Here, let me try again. Okay, one more time. Unhelpful.